A textbook definition of cancer would be something along the lines of, cancer is a group of diseases involving uncontrolled cell growth. Our DNA is a set of instructions that takes us from being a fertilized egg no bigger than a grain of sand, all the way into becoming a full-grown adult.
When we're still growing in the womb, our DNA tells our cells how to develop into our organs and tissues. Even after we're born, our DNA continues to guide our cells by instructing them when to divide, repair, and even die to allow for replacement with new cells.
For example, when you get a cut, your DNA springs into action to heal the wound. It sends signals to the stem cells around the cut to start dividing and producing new cells to replace the damaged ones. So the skin heals. This intricate process encoded in our DNA ensures we can recover from injuries and our bodies maintain all normal functions.
But sometimes, the instructions encoding these processes become altered or lost because the DNA encoding them gets damaged.
The cell has to make an exact copy of the DNA. And in the process of division, where the cell is essentially copying the DNA, mistakes happen.
When this happens in cells, they may begin to divide in an uncontrolled manner, without any balance or restraint.
Most mistakes are non-consequential, meaning that they're not likely to cause a problem. The majority of our DNA is not coding for something important. But the more you make mistakes, you're likely to make a mistake that actually makes a difference. That's what we call the driver mutations, the mutations that are more likely to cause a cancer.
When these rogue cells multiply, they can form a mass known as a tumor.
And that's essentially what cancer is, an accumulation of mistakes. And these mistakes in your DNA will then release the brakes off of your cells.
Normal cells are programmed to die after a certain amount of time as specified in our DNA. This controlled and planned process of natural cell death is called apoptosis.
Apoptosis is what happens to embryos, for example, so that they can be reshaped. Without apoptosis, our fingers would be webbed. So apoptosis is an important process. It's part of the normal life cycle of our cells in the body.
However, cancer cells evade the natural process of apoptosis and survive much longer than they should.
Now let's go back to that cut. Normal skin cells live 2 to 3 weeks before dying off and are replaced, ensuring the skin heals properly. But if cells in the cut were cancerous, instead of dying off through apoptosis, the cancer cells would just keep accumulating, eventually forming a mass or tumor. But not all tumors are cancerous.
A benign tumor continues to divide and it grows and it lumps together, but it's not affecting your nearby tissues, it's not invading them, and not affecting the body. Cancerous tumors, on the other hand, are aggressive. They do tend to invade the surrounding areas and can sometimes also, little pieces of that lump can break off and spread into other parts of the body, spreading the cancer so that it can start growing and dividing somewhere else.
Our cells are very good at catching these mistakes and correcting these mistakes, but some will seep through.
Malignant tumors, just as they find a way to avoid dying and they find a way to divide uncontrollably, they also find ways to create their own supplies of blood.
The cancer cells are recruiting more blood vessels so that they can have their own blood supply so that they can grow even more. In fact, credit to the term cancer is given historically to Hippocrates. It is called carcinous either because it aggressively latches on like a crab, or maybe because of the abnormal blood supply makes it have this tentacle-like appearance.
They also are able to turn on and off different parts of the immune system, and that also affects the way that the body looks at those cells, because though they're causing a lot of problems, the immune system is not recognizing them as a problem.
That's why I tell all my patients cancer is a disease of time, because the older you are, the more cell divisions you've had, and therefore the more mistakes are likely to have accumulated in your DNA.